Hello, I'm Jared Skeens and welcome to Quick Fix. Today we want to look at our IGCSE May-June of 2019 paper 41, and it's a 2.5 hour test. We want to look at go through the problems together. Again, don't just focus on the answer or even just how to get the numbers together, but make sure you focus on the thinking strategy of how to think your way through the problem. And so let's get right into it. This first one is on transformations. Now, in the new syllabus cycle, you don't have to do the matrices part. Matrices have been eliminated from the syllabus, but we still need to do the transformations part. So as we move down here, our first one is to translate shape T by this column vector of -1, 6. So this column vector is your x over y. So our T, which is right here, it's the object, and these others are the images that we end up with uh, after we translate it. So we want to take this T, you go to each vertex. So if we start here, follow the pointer, and a -1, 6 means back 1 and then up 6. So 1, 2, 3, 4, 5, 6, put a dot. If you start from this corner, back 1, up 6, put you here. Start from this corner, back 1, up 6, put you here. Start from this corner, back 1, and up 6, put you there. So we draw that in and we label it image A. Second one says rotate shape T about the point 5,3, which 5,3 happens to be the corner here, and then through 180 degrees. So 180 degrees means basically the opposite direction here. And so we're rotating it around this point here, 5,3. So if you draw kind of a straight line through here, this point here translates over to here. This corner goes straight through over to here. This corner goes straight through over to here. You just count how far you are away, 2 units away, 2 units away, 1 unit away, 1 unit away, and then uh, over 3, up 2, over 3, and you get your corners and you label that image B. Then describe fully the single transformation that maps shape A onto shape B. So we want shape A to go over to shape B. You might look at it and you might think that it's a reflection, but a reflection, this pointy part here would be on the same, would be over here, not over here. So it's not a reflection. It's also not a enlargement because the size of it is staying the same. So this one is being rotated around, and so you're going to call it a rotation. It's rotated 180 degrees, so you can see that it's turned completely over 180 degrees, and you need the point of rotation. So the point of rotation, because it's 180 degrees, it's just going to make a straight line between our corners here because it's 180 degrees. So halfway in between these 2 points is this point right here. It seems a little awkward because it's a decimal. So this one is 4.5 and 6. So our center of rotation, 4.56. So you get 3 points, one for each of these pieces. Rotation, 180 degrees. Doesn't matter whether you say clockwise or counterclockwise because it's 180. And then your center of rotation again is 4.5 and 6. Then wants you to reflect shape T in the line y equals x. So here is the line y equals x. Y equals x is like y equals mx plus c, where the plus c is an understood 0. and the m is an understood slope of up 1 over 1. So if you go up 1 over 1, you get this line here. It makes a 45-degree angle with the x-axis. That is your line of symmetry. So all you do is you go to each vertex, you go perpendicular to the line of symmetry, and then the same distance on the other side. So you have a half a square to the line of symmetry, and then half square on the other side, and put your point. Over here, again, it's half a square, half a square. Over here, it's a whole square diagonal here, and then a whole square diagonal here. From this corner, it's 2 squares diagonal, so you go 2 squares diagonal the other side, and you get this point. So make sure all your coordinates, you go to the line of symmetry, perpendicular to the line of symmetry. However much space that is, that's how much space you do on the other side of the line before you put your point. So this is BI, letter B, part I, and find the matrix that represents the transformation of part BI. Well, again, I crossed it out. You don't have to do it, but what you would do is you take a point from your object. So here's the point 2, 1. And so I wrote 2, 1, and you look at what does it become? Well, it becomes 1, 2. 0.21 becomes 1, 2. So if we look at it in terms of x and y, the x and y switch positions. Instead of 2, 1, it's now 1, 2. The x is now in the second position and the y is now in the first position. So what you want to use as your point of reference is the identity matrix, where you have 1, 0, 0, 1. The top row represents your first position. The bottom row represents your second position. The top column represents your x, and the second column represents your y. So your x from the first position is now going to the second position. So if you look over here, remember your x is now, which is the first column, moves from the first position down to the second position. And then your y, which is the second column, moves from the second position up to the first position. So again, the first column is your x, the second column is your y. The first row is the first position, and the second row is the second position. So x goes from first position to second position. So it goes from here down to here, and your y goes from second position to first position, goes from here and moves up. So the others are zeros. So this would be your matrix to represent that. If you wanted to double check, you could multiply this matrix, the 2, 1, times this matrix here, and you should get 1, 2 as your answer. Okay, so if you take 2, 1 and multiply it by 0, 1, 1, 0, you will get 1, 2 as your answer to that multiplication. So you can double check it with matrix multiplication. Okay, that was for free because you don't have to do it. For those of you who are like to learn extra things. So moving on to number 2, we get to graphical solutions. Here it gives you a cubic, y equals x cubed plus 3x squared plus 2. And because you haven't learned how to graph cubics per se, they give you this XY chart. There's a couple of values that you need to calculate yourself. So you got to put in this -3 into this formula to calculate the y. Don't forget to put parentheses around your negatives, especially when they have exponents. So calculate that out. You should get 2. When you plug in 0, obviously the x cubed cancels, the 3x squared cancels, and you're only left with 2 there. And when you plug in a 1, you get 1 plus 3 plus 2, which is 6. So these two over here are easy to do. You can do in your head. This -3 you probably need to do on calculator. You'll still get 2. So that's 3 points there. So that's complete the table. Then you want to draw your graph. So you need to go through and you need to plot all of these points. Takes a little bit of time. Notice you get 4 points for this. So take your time, pay attention to your signs and your X and Y coordinate. So you get this point, and I marked all these points through here. So you can double check that with your work and then draw your graph. When you draw it, these are curves. Graphical solutions deal with curves. You shouldn't have any pointy places on your graph. So if you've got a pointy spot somewhere, you probably did something wrong. You might have a wrong coordinate. So make sure you draw it smoothly. I like to put my wrist down on the paper and rotate it to get that curve action going. And so here you have a concave down part on this section, and then here's a concave up. So try to make it a smooth curve as much as possible. Then you're going to use your graph to solve for where this that you just graph equals 0. In other words, where does it cross the x-axis? The x-axis is the y equals 0. So your graph is the x cubed plus 3x squared plus 2. The x-axis is the y equals 0. And where those two are equal is where they intersect. So that would be not up here, that's a different line, but right here, this one right here is the point of intersection with the y equals 0 or the x-axis. So you find that value right there. So here's -3.1 and or -3 point 2.4 1 2 3 4 5. So you kind of have to guess a little bit, but you want to be close. I put -3.2, and if the Cambridge mark scheme allows you anywhere between -3.1 to -3.3. So here you can see the -3.1. Over here's the -3.3. And so somewhere between -3.1, -3.2 is what it looks closest to. Now, by drawing a suitable straight line, solve this equation. If you notice, this equation is different from our original one. So because this is graphical solutions, we are solving it through graphs, not through algebraic manipulation or algebraic solving methods. So don't try to solve this algebraically, especially since you probably haven't been working with cubics yet anyway. So what you want to do is you want to compare the original with this new equation they've given you. So notice the x cubed is the same. So we're going to leave that alone. We have a 3x squared, and it's also 3x squared. So we're going to leave that alone. Notice there's no 2x in the original. There's no 2x up here. There is here. So we're going to subtract that to the other side. And then here there's a 2 and here there's a 2. So we're going to leave that alone. If anything is different, you either add or subtract to make it the same as the original. Anything that is not the original, you move to the other side. So here's the original, which is the graph that we already have on there. And what we got rid of, or what we moved to the other side, is a -2x. So that now is what we're going to graph. Y equals -2x. So if y equals this and y equals this, then that means they equal each other. So y equals -2x. Again, y equals mx plus c. The plus c is an understood 0. So right here, and then the -2 is your slope. Now pay attention to the scale, because the scale going left and right is different than the scale going up and down. You don't go by the number of boxes, you go by the scale. So it's a -2 over 1. So a -2 is actually 4 boxes down, and then 1 looks like about 10 boxes across. Okay, so you got to look at from 0 to -5. -2 is right here. and then over 1, here's your 1, so that's your next dot, and you draw a straight line through that. And where they equal is where these two graphs intersect, which is right here. So you follow that down, and I put negative 2.5. They allow anything from negative 2.45 up to negative 2.6. Notice the window is not very big, so you do have to be quite precise on your graphing for this. Now it says for this particular interval, the equation uh, of the original graph equaling a constant. Remember, a constant is a horizontal line. Y equals a constant is a horizontal line, like the x-axis is y equals 0, y equals 1, y equals 2, or y equals negative 1, y equals negative 2. So your y equals a constant is a horizontal line. So you want to find where the value of k has 3 solutions, and k is an integer, meaning no decimals or fractions. So the horizontal lines here can be anywhere from 15 all the way to negative 5. Horizontal lines from 15 to negative 5, only integers, so no fractions, no decimals. And we're looking for the place where our horizontal line has 3 solutions or 3 intersecting points with the original graph. So if you notice up here at 15, it's not even touching the graph. That's like no solutions for this particular interval. If you get down here at 10 and you go horizontally, you only intersect once. If you get down to whatever this value is right here, it touches once, twice. So between here and down here, where again, the bottom of this curve going over and this one, it also touches twice. Everything below that, your horizontal lines are only going to touch once. That is the original graph touching a horizontal line. Here it's only going to be one intersecting point. Up here it's only going to be one intersecting point. At the top and at the bottom of these curves, you're going to get 2 intersecting points. So between this top part and this bottom part here, all of this in here is going to have 3 intersecting points. So notice 5, 4, and 3 could have 3 intersecting points. For example, look at 5. If I follow it across, here's 1 intersecting point, 2, 3. If I take 4, here's 1, 2, 3. So I chose 4 because it's right in the middle. It's obviously got 3 intersecting points. They allow either 3, 4, or 5. So notice that 2 and 6 would put you into the 2 intersecting points and not 3. So any one of those 3 numbers would work, but you need to understand what it means for it to equal a constant. It means y equals a constant, which is a horizontal line. Which horizontal line that is an integer gives you 3 solutions or 3 intersecting points with the original graph. Moving on, we've got this kind of weird diagram here. Notice there are 2 right triangles and then a non-right triangle. So there's going to be a lot of questions with regards to this. So first, calculate the perimeter of this field, starting with A and working all the way back to E. So I just put A to B, B to C, C to D, D to E, and then E back to A. So start with the obvious ones. A to B is already given, it's 100. B to C is 170. C to D, we're going to have to calculate that one. D to E, we're going to have to calculate. And then E to A is given 50. Okay, so let's calculate the values here. For the 80, we have, let's see here, where did I put that work. Here it is right here. So that is the C to D. Notice this is a right triangle, so we can use the Pythagorean theorem where 170 is the hypotenuse and 150 is a leg. So here CD is what we want to solve for. So CD squared plus BD squared, which was our 150, and the BC is 170. So this squared plus this squared equals the 170 squared. So you do that, subtract the 150 squared, you get 6,400. Square root both sides, your CD is 80. You should be able to do this. This is just Pythagorean theorem with the right triangle. So you get CD being 80, and we plug that in here because it wasn't given. We also have to find this value. Notice this is also a right triangle, except this time we're finding the hypotenuse. So again, you use the Pythagorean theorem. 50 squared plus 120 squared equals the DE squared. And you add those up, you get 16,900. Square root it, you get 130. So we plug that in for the DE. Now you just add those up and you get a perimeter of 530. So that's not too bad. Now it wants us to calculate the angle of ABD. So if you look at ABD is this angle right here. I know there's several markings on here because you're answering several questions, but A to B to D is this angle right here, and it is inside the triangle that does not have a 90 degree. And if you notice, we have a side, but not the angle. We have a side, but not the angle, and we have a side without the angle. So we don't have a pair that includes both the side and the angle. If you had a pair where you had both the side and the angle, you could use the law of sines. But since we don't have a pair, we have to use the law of cosines. So the law of cosines, where we want to solve for this, means this is our side that's by itself, and these two that are next to the angle are together. So the side that's by itself starts off 120 squared equals, and then the other two sides that are adjacent to our angle, 100 squared plus 150 squared minus, so I like to call it C squared equals A squared plus B squared minus 2AB. That is these two values here. And then cosine C, where C is opposite this C here. This is little c, this is capital C. So that's the formula I like to use. C squared equals A squared plus B squared minus 2AB cosine C. And this side and this angle are opposites. So the 120 is opposite the angle that we're trying to find. We're trying to find this angle C. So when you work this out, be careful. Here, the squares are easy. Multiplying this part is easy. This is where you have to be careful right here. It looks very tempting to take 32,500 and subtract 30,000. That's easy to do, but it's incorrect. Remember, multiplication comes before subtraction. So we cannot subtract at this point. What we need to do is subtract our 32,500 from this side over here. And then to get rid of this 30,000, because we can't subtract it, we need to divide it. To get rid of that multiply, we divide. So we divide both sides by the negative 30,000. And that then makes this a positive 0.603 repeating. And our cosine C is now by itself. Then inverse cosine the 0.603. And remember to set your calculator to degrees. And you get 52.9 degrees. Remember, Cambridge with degrees is only one decimal point. So 52.9 degrees. So this is your law of cosines, and we use the law of cosines because we don't have a side and an angle as a pair. We only have sides with no angles. So since there are no pairs, we have to use the law of cosines. Now calculate the angle CBD. CBD is this angle right here. CBD, this one right here, and it's a 90-degree triangle. So that means we can use SOHCAHTOA. So using SOHCAHTOA, what we have from this angle that we're looking for is opposite and hypotenuse. So opposite and hypotenuse, that's our SO. So sine of the angle equals the 80 over 170. So the angle is the inverse sine of the 80 over 170, which is 28.07 or 28.1 degrees. Then we have a little bit of bearings. The point C is due north of point B. Find the bearing of D from B. So notice it says find the bearing of D from B. So we're starting from B. So notice I put the little north, south, east, west little axes here at the corner. You always start from the north. And it said C is directly north of B, meaning this line right here is a straight north and south line. So we're starting from this north. You rotate clockwise until you are facing the direction that you want to go, which is D. We want to face D, which is this dotted line here. So we'll start from here, rotate around clockwise until we hit this dotted line. Now we just solved for this angle right here. This angle right here was 28.1, and the full circle is 360. So 360 minus the 28.1 is 331.9. So 330.19 degrees would be how far it is from here all the way over to there. So that's how you do bearings. Then calculate the area of this entire field. So notice we've got three triangles here. We have triangle ADE, ABD, and BCD. Two of them are right triangles, so we can just use half base times height. We could use half base times height with this middle triangle, but it would be kind of difficult to find how the base and height work with this odd shaped triangle. So we're going to use a trigonometric formula for that one. So here are our three. You can kind of look at the problem at the diagram. So the triangle, the area of the triangle BCD, 1/2 base times height. And you can figure out which one's the base and the height, doesn't really matter, but it's a right triangle. So 1/2 the two sides, and you get 6,000. And then the ADE triangle is also a right triangle. So again, half base times height. And you multiply that out, you get 3,000. And then the middle triangle, the ABD, is not a right triangle. It's difficult to do the base times height formula. So we're going to use the trigonometric formula. 1/2 AB sine C. In other words, any two sides and the included angle. 1/2 AB sine C. If you look at it, here is our two sides, 100 and 150, and we already found the 59, I think it was, or 52.9. We found that one, which is the angle here. So any two sides in the included angle, 1/2 AB, that's the two sides, times sine of the included angle. This is your trigonometric formula for a triangle, and you get 5,981.88. Add all that together, you get 14,981.88. Notice it wants the answer in hectares. 1 hectare is 10,000 meters squared. So this, because its area is already in meters squared, so we just divide by 10,000 and we get 1.498. Correct to three significant figures would be 1.50 hectares, or 1.5 hectares. You do need to put the 0 because you need three significant figures. So don't just put 1.5, you need 1.50. Moving on, here we have 14 students test scores, and we need to find all of these statistical values. So the first thing we're going to do is quickly rewrite them in order from least to greatest. So it might take you a little bit of time. Notice I wrote a value under each one. That way when I get to the end, I know I didn't miss a value. So count up the lowest number here is 20. The highest is 27. Count up how many 21s. Just make sure you have it in order. Make sure you still have 14 of them so that you didn't miss something. So first, find the range. Range is highest minus lowest. 27 minus 20 is 7. Then find the mode. Mode is the most occurring value, which is 21. 21 is the most occurring value out of this list. Then find the median. Median is the middle. There's 14 students. So if you divide it in half, it goes right here. You have 7 on this side and 7 on this side. So you don't have an exact middle. If you have an exact middle, that is your median. In this case, we do not have an exact middle. So we need to average these two numbers. No, we're dealing with this bottom row of numbers here. So the 22 and 23, the average of those two is 22 and a half. That is your median. And then you find the mean, which is the average. The average means you add them all up. You get 318. You divide by the total 14, and you get 22.71. To three significant figures is just 22.7. Now, a student is chosen at random. Find the probability that the student has a test score of more than 24. More than means you don't include the 24. So here's where your 24 is. More than 24, there are 3 values, more than 24. Total of 14 values. So 3/14 is your probability. Now, moving on, Petra records the score in each test she takes. The mean of the first n scores is x. Okay, now what you have to understand is mean is your average, and there are n number of scores, and the average is x. So if you wanted the total score, you take how many tests there were times the average, and that will give you your total points, n times x. The mean of the first n minus 1 scores is x plus 1. So again, if you want to find the total number of points, you multiply the number of scores, n minus 1, times the mean, which is the average. And when we multiply those together, you get nx minus x plus n minus 1, doing the smiley face method here, n times x, negative 1 times positive 1, n times positive 1, and negative 1 times x. You get these 4. So find the nth score in terms of n and x. Well, the nth score is the last score. So if we take the total of all the scores minus the total of all the scores before the last one, and we subtract the two, that will give us the last score in terms of n and x. So here's the total of all the test scores minus the total of all the ones just one test value below or before the last one. Don't forget to put that in parentheses. A lot of students don't quite use parentheses efficiently, so we have to subtract this entire thing. That means the negative distributes, changes all the signs, and so the nx and this nx cancel, meaning your last test score is x minus n plus 1, and it's in terms of n and x, so you don't actually have to get the actual value. Moving on, we've got this table here. It's got frequency as in the number of days. We have these boundaries, these groups here with the boundaries for these different temperature levels, and it wants us to calculate an estimate of the mean. So when you find the mean, you need to take the frequency times the mid-class value. So this top row up here, I've went through and written all the mid-class values, the middle between each class boundary here, and then you go that mid-class value times the frequency, which is 50 plus 12.5 times 85 plus 17.5 times 100 plus 22.5 times 120 plus 30 times 10, all over the total frequency, which is during 1 year. So of course, if you add up all this, you should have 365 days. And when you divide that, you get a mean of 16.609. To three significant figures is just 16.6. Then it wants us to draw a histogram. In order to draw a histogram, you need frequency density for your height. Frequency density is frequency divided by class width. So here's the frequency. The class width is what I wrote down here in this bottom row, class width. So 10 minus 0 is 10, 15 minus 10 is 5, 20 minus 15 is 5, 25 minus 20 is 5, 35 minus 25 is 10. That's the class width. So frequency divided by class width, here this will give you 5. This gives you, what does that give you? 17. This one gives you 20. This one gives you 24, I think. And then this one gives you 1. So those frequency densities are your heights. So from 0 to 10, your x-axis just follows these boundaries. So 0 to 10, 10 to 15, 15 to 20, that's your x-axis values, and the frequency density is your y-axis. So from 0 to 10 had a frequency density of 5, from 10 to 15 had a frequency density of 17, from 15 to 20 had a frequency density of 20, and then 24, and then 1 for that last section. And so frequency density is frequency divided by class width. Now we have this kind of racetrack looking shape. Although it's a garden pond, looks to me like a racetrack, but it's the surface of a garden pond made from a rectangle and 2 semicircles. So the rectangle measures 3 meters by 1.2, and it wants us to calculate the area of the surface. So the area of this, we have 2 semicircles, so the 2 semicircles put together make a complete circle. So that's pi r squared for the area. Then our rectangle is just length times width. So as far as the length times width, that's pretty easy. 3 times 1.2. But for the circle, it's radius. Radius is half the diameter. So half of 1.2 is 0.6. So pi r squared plus the length times width gives you 4.73 meters squared is your area. Now it says that the pond is a prism, meaning it's a 3-dimensional object and that it has a depth of 20 centimeters. So a prism being that area just goes straight down for 20 centimeters. And so we take our 4.73, which is already our area, and it's in meters squared. Notice our height or depth is in centimeters. So be careful of the units. We're going from meters squared now down to centimeters. So we need to convert that first. So 1 meter is 100 centimeters, and we need to square it because we're in area, not linear. So we multiply this out, and it gives us 47,300 square centimeters. That's the area in centimeters squared. Now times the depth, 20 centimeters, gives us 946,000 centimeters squared. Now you say, why did you convert to centimeters squared? Why didn't you convert the centimeters to meters? Well, because it's looking for liters. and our conversion for liters is centimeters cubed. Remember, 1 centimeter cubed equals 1 milliliter. So 1 liter is 1,000 centimeters cubed. Hopefully you remember that, maybe from physics or from math, either one. Uh, you need to know that conversion of liters is 1,000 centimeters cubed, or 1 centimeter cubed is 1 milliliter. So you divide by 1,000 and it gives you 946 liters. Now, after a rainfall, the number of liters in the pond is up to 1,007. So we need to calculate the increase in the depth of the water in the pond. Okay, so the increase. So we take our 1,007 liters and we're going to convert that to centimeters cubed. So for each liter, it's 1,000 centimeters cubed. So multiply by 1,000. So that gives us 1,007,000 centimeters cubed. Notice we're going to divide by the area because the surface area has not changed. It's only the depth that changed. So the area is still the same shape, same area. So we divide by that and it gives us our new depth of 21.29 centimeters. It wants the increase in depth. So we take the new depth minus the old depth, and we have 1.29 centimeter increase from the rainfall. Moving on, we now have a Venn diagram, and it says that F, which is this circle here, is for students who play football. B is for students who play baseball. E are the students in a school. There's 240 students in this school. Complete the Venn diagram. So there are, let's start, there's 120 total that play football. There's 40 total that play baseball. There's 90 that play football, but not baseball. So this one is our starting point here, 90, play football, not baseball. There are a total of 40 students that play, or 120 students play football. So 120 minus the 90 give us the 30 that goes here. So 90 and 30 gives us our 120. So these 30 also play baseball. There's 40 that play baseball, so 40 minus 30 give us the 10 that play baseball but not football. We add those up, that's 130 subtracted from the 240, give us 110 students that don't play either football or nor baseball. So that's how you do that. Now, this is a notation here. This N is how many. It's not what numbers, it's how many values are. And this little prime mark means not F, not B. And then this symbol here is your intersection of not F and not B. So how many values are not F intersected with not B? So here's F. So not F would be this outside, and we see that there's this 110 and this 10. Those are outside of F, not F. Intersect with not B. Well, here's B. So not B would be the 90 and the 110. So the intersecting is what is common to both of those, which is the 110. A student in the school is chosen at random. Find the probability that this student plays baseball but not football. So there's going to be 10 students that play baseball, not football, out of a total of 240 students, and that would be your probability for a student that plays baseball and not football out of all the students in the school. Now, 2 students who play baseball are chosen at random. Find the probability that they both also play football. So the ones that play football are 30 out of these 40. So 30 out of the 40 play baseball and football. So your first draw would select one of those 30. Now, after you've selected that person, there are now 29 of those 30 left and 39 total left. For the second draw or person selected, you multiply those together, you get 870 over 1,560. Moving on, here's this formula here. It gives you all the values, the t, the u, and the a. Notice the a is negative, so be careful of that. The trick here is give your answer in standard form. Standard form is the same thing as scientific notation, depending on what terminology you've learned. Standard form or scientific notation, correct to 4 significant figures. So there's two things you can do. You can either multiply it all out on your calculator and manually convert it to scientific notation, or you can set your calculator directly to scientific notation. So to do that, go to your calculator, go to the menu button, click on the menu button, and you'll look through the numbers, or for some of your calculators, you might have to hit the menu several times and look through the lists until you see the SCI. That stands for scientific notation. And you want to click that button. Then it will give you numbers. You need to enter a number from 0, I think it is, to 9, has like a 0 squiggly 9. And so because this wants 4 significant figures, you're going to hit the number 4. And after you've done that, you can just go ahead and plug your values in. So notice the U is 104.3 times the T, 26.5, plus 1/2. A is a negative, so don't forget the negative, and then T squared. So make sure you're putting it in the calculator so that it follows the order of operation. Squareds have to go before multiply, and then you multiply this out and do the addition with this multiply. So make sure you follow the order of operations. And if you've set your calculator to scientific notation, you should get 1.991 times 10 to the third power. Now, if you want to get your calculator back out of scientific notation, go back to your menu, find, I think it's NOR for normal, and then you hit that button, and then it will give you a 0 squiggly mark, and I forget what the second number is, but you want to hit the number 2. I hit the number 2, and is what I hit for that, to get it back to normal, to get it out of the scientific notation mode. So your menu, SCI, and I think it's NOR, I don't have my calculator right here with me, is how to get it back out of scientific notation. Now it wants you to take that formula and to write, to rearrange it to write A in terms of UT and S. In other words, make A the subject. Right now, S is the subject. We want to make A the subject. We're isolating the A. So since A is in this term here, we're going to subtract the UT to the other side. So subtract UT gives us S minus UT. Here's the 1/2 AT squared, so that the A is in this term here. Multiply both sides by 2 to get rid of the 1/2. Divide both sides by T squared. Now you have A as your subject. So that shouldn't be too difficult. You get 3 points for that. Moving on. Sorry, this is a little blurry. This page turned out a little blurry. There's 2 rectangles. This is X minus 1, and this is 2x plus 3. Over here is an x plus 1 and an x minus 2. It says the difference between the areas of the rectangles is 62. Difference means you're subtracting the areas, and that will equal 62. So areas means we have to multiply width times length. So here's an x minus 1 times a 2x plus 3. The difference is subtraction. This area is x plus 1 times x minus 2, and this difference is going to equal 62. So multiply these binomials out, smiley face method, you get 2x squared plus x minus 3. Minus, again, don't forget to put parentheses because this difference is the difference of this whole thing, not just the first part. So when you multiply this out, you get x squared minus x minus 2. Again, one of the biggest mistakes is when students don't realize they need parentheses because this minus goes to everything that follows it, not just to the first term. So that negative has to distribute. So a minus x squared. So 2x squared minus x squared is 1x squared. X minus a negative x, meaning plus x, gives you 2x. Negative 3 minus negative 2 or plus 2 will give you a negative 1 equals the 62. Subtract the 62 to the other side, and you get what they want. X squared plus 2x minus 63 equals 0. Now they want you to factor that. So the factors of 63 that subtract to give you 2 are 9 and 7. 9 minus 7 will give you a positive 2. And so there's your factors. That's just straight out factoring, trinomial factoring, x plus 9 and x plus 9 and x minus 7. Now it wants us to solve this. So if you solve this, you get x equals negative 9 and x equals 7. And it wants us to go ahead and find the difference between the perimeters. Okay, between the perimeters, not the area, the difference between the perimeters. So remember what x represents. X is representing a value of length. We can't use the negative 9 because that will give us a negative length. We don't work with negative lengths. So you need to pay attention to context. The negative 9 isn't going to work. We use the 7. So 7 minus 1 gives us the 6 here. 2 times 7 is 14 plus 3 is 17. 7 plus 1 is 8, and 7 minus 2 is 5. That's where these numbers came from. So to find the perimeter, we have a 6 and a 17 times 2 because there's 2 of each of those, and then an 8 and a 5 times 2 because there's 2 of those. And so we have here are 6 and 17 times 2 is 46, and 8 and 5 times 2 is 26. The difference between the perimeters is 20. Now we have the price of a book increases from $2.50 to $2.65. Calculate the percentage increase. So first let's find the increase. So the higher minus the lower gives us an increase of 15 cents. Percentage increase means we divide it by the original price. Okay, make sure you divide it by the original price. So 15 cents out of $2.50, you move the decimals over twice, divide it, turn it into a decimal, you get 0.06. Remember to, as a percent, you move the decimal over twice here to make it a percent, so it's a 6% increase. Part B, Scott invests $500 for 7 years at a rate of 1.5% percent per year, simple interest. Your simple interest formula is I equals PRT, where P is the principal, which is the $500. R is the rate of interest, but you need to change it into a decimal, and T is time, which is 7 years. So here's our I equals PRT. I equals P again is the principal. R is the rate. So I like to change it into a decimal. Just move the decimal over twice, 0.015. Some teachers will teach you to make it a fraction over 100. They'll put 1.5 divided by 100. I don't like to do that for 2 reasons. One, I don't like a fraction in my formula. And second of all, I don't like to have a decimal in my fraction. So I prefer to just move the decimal over twice and make it 0.015, and then 7 years. Multiply it out, you get 52.5. Now remember, this is the interest, not the total amount. This is asking for the value of his investment. This wants the total. So you need to add your interest back to the principal. You started with 500, you earned $52.5, $52.50 in interest. Add those together, so your total is now 552.50. So make sure you're paying attention to the question. Does it only want interest or does it want the total amount? Now we're dealing with in a city, the population is increasing exponentially at a rate of 1.6% per year. Now, population increase is actually the same formula as compound interest. Compound interest, population increase, um, any kind of exponential growth or decay model is going to use the compound interest formula. So I just changed the variables to represent this question. So this is the population after time equals the original population, population subscript O, original population, times 1 plus the interest. If you were decreasing, you would subtract the rate, not the interest, sorry, the rate. So 1 plus the rate because it's increasing, and then your time is the exponent because this is an exponential increase here, exponential growth. So the 1 represents your original 100% of your original population plus the percent of increase. So again, change your rate to a decimal, or if you're used to using the fraction over 100, you can do that, but I like 0.016. Plug this here into your calculator, 1 plus 0.016 raised to the 20th power, and you get 1.374. Notice we have two unknowns, which might make you a little nervous, but we're not actually solving for either one of those. We're solving for a percent increase. So don't worry about it. You have your final population in terms of your original population, 1.374 times the original population. So you got two unknowns here. Notice it says the percentage increase. This problem is just like what you did up here. You find the increase and then you find the percent. So we find the increase, the higher value, 1.374 p subscript 0 minus your original value is 1 times p subscript 0, or your original population. You subtract, gives you 0.374 of your original population. That's the increase. Now, because it's a percentage, you're going to divide by the original population. So this ends up canceling out your variable that you didn't know what to do with and leaves you with a decimal. And notice this is a percent increase, so you got to move the decimal over twice and you get 37.4% increase. Now here we have a population of a village is 6,400. It's the original population, and then after 22 years, it's now 2,607. Notice the population has decreased. So we're going to put a subtraction here, okay? And our variable is the R%, the rate here. So here's our final population, our population at the end of time, 2,607 people. Here is our original population. Notice it's the same formula as right here. Population after time, population original, except this time our population, instead of increasing, is decreasing. So the original, instead of going up, our original 100% is going down. Now we have our percent. So what I did is I changed it to a decimal because that's what you do with the formula. So instead of R, it's moved the decimal over twice, 0.0R. That's not an OR, it's 0.0R. And then the time is your exponent, 22 years. So we're solving for the R. So the first thing that we're going to do is divide by the 6,400, and that's going to give you 0.4073. Second thing we're going to do, and I put it out here, is we need to get rid of that 22. So we need to root with the 22nd root. Okay, so you might have to use your root key and go in and change that root to a 22 instead of a square root, or you can just raise it to the 1 over 22 power. You can use an exponent 1 over 22. It's up to you, but you need to do that to both sides. It cancels the 22 over here. On this side, if you do that correctly, it should give you 0.9599. So use the 22nd root or parenthesis raised to the 1 over 22 power to get this value here. Now we want to add the 0.0r to this side to make it positive, subtract the 0.9599 to this side, and so our r now equals 0.04001. Move that over 2 places, that decimal over to make it a percent again. So you move it over 2 places. So our r, which is what we wanted back here, our percent is at 4%. And since you're doing 3 significant figures and we had extra values here, it wasn't exact. So you should put 4.00% to make it 3 significant figures. So don't forget that it's not exactly 4. Moving on to functions, here we're given 3 functions, f of x equals 7x minus 2, g of x equals x squared plus 1, and h of x equals 3 raised to the x power. I put up here P1 functions part 1 and 2. I have a video series for AS and A-level math. So if you're interested in functions, here are 2 more videos, Pure Maths 1, functions part 1 and 2 in my AS level math videos can give you information on that as well. So A here is a composite function. Find g of h of 2. This is a composite function. So you work inside out. So 2 goes into h, and then that answer goes into g. So first we start with the 2 and put it in the h, which is over here. So you plug a 2 in, 3 squared is 9. Now we put the 9 into the g. So g of 9, put a 9 in here, we get 9 squared plus 1. 81 plus 1 is 82. So that is our answer. You work from the inside out. 2 goes into h, that answer then goes into the g, and what you get from that's your final answer. Find f negative 1 of x. This means find the inverse function of f. So here's our 7x minus 2. Remember, your f of x can be replaced with a y equals 7x minus 2. So to find the inverse function, you follow 2 things: switch x and y, solve for y. Switch x and y, solve for y. So here I switched the x and y. So the x moves over here, the y moves over here. And now solve for y. So add the 2 over here, get x plus 2, divide by the 7, you get x plus 2 divided by 7. Now just take your y and change it back into our function notation, designating it as the inverse function of f, x plus 2 over 7. Now letter C, here we have this kind of composite function equation, g of x. So we need to put the x into g and then put the g of x into g again. So when we put x into g, we get x squared plus 1. And when we put our g of x back into x, now we have x squared plus 1 into the x gives us x squared plus 1 squared, and then plus 1 again. So the g of x is being put back into the g function again. So here's the g of x put back into the x squared plus 1. So we need to square this, and that gives us x to the 4th plus 2x squared plus 1. And then this plus 1 out here gives us plus 2. And what we want to do is equate coefficients. In other words, we're looking at the left-hand side, comparing it to the right-hand side to get this ABC. So the A is on the x to the fourth, so that has an understood coefficient of 1. The B is on the x squared, that coefficient is 2. And then the C is the constant at the end. So we get 1, 2, and 2 as our answers for that. Letter D, find x when f or h of f of x equals 81. Again, we have a composite function equation. So the f of x needs put into the h. Our f of x is the 7x minus 2. We put it into the x value in this h function. So we get a 3 raised to the 7x minus 2, and it equals 81. So when you're dealing, this is actually exponentials. Your variable is in the exponent. So what you want to do is you want to get a like base. So we can convert 81 into base 3. It's 3 to the fourth power. And to do that, just keep dividing 81 by 3 and see how many times you get 4 of those. So 3 to the fourth power. And again, I mentioned this in the previous video on paper 21. I don't really like it when Cambridge does it. They just have you poof the bases. When you have the same base, they cancel it. Well, it's not like magic. They don't just poof. You're actually using a logarithm base 3 to both sides to cancel out those 3's. But since Cambridge hasn't taught you logarithms yet, they just have you poof the base. So it's not really good mathematics because you're not showing the step of how those 3's disappear. But yes, they do disappear using logarithms, and you get 7x minus 2 equals the 4. And then you just solve for x. So add 2 to both sides, you get 6, divide by 7, so x equals 6/7. Moving on here to number 10, the volume of each of the following solids is 1,000 cubic centimeters. Calculate the value of x for each solid. So a cube with sides of length x. So a cube is going to have a volume of, well, side cubed or x cubed because the side is x. So you have x cubed equals 1,000. Cube root both sides. So each side or each value of x is 10. Sphere has 4/3 pi r cubed. So you put 4/3 pi r cubed equals 1,000. Solve for the r because your radius is the x. So divide by 4/3 pi. Use your pi key on your calculator. You get 238.73. Then cube root to get rid of that cube. R equals 6.20, 6.20 for that. And then we have this cone here, and the cone is 1/3 pi r squared h, but we need to find the h, and we need to find the h in terms of x. So this is a right triangle. We have two sides of the right triangle, so we can use the Pythagorean theorem. X squared plus h squared equals x root 5 squared, and solve for your h, and h equals 2x. So now that we have the 2x, now everything is in terms of x. So that gives us 2/3 pi x cubed equals 1,000. So we used this formula here, but we had to find the h in terms of x so that we can get only x as the variable. Divide by 2/3 pi and then cube root so that x equals 7.82. Moving on, we have this wedge here, this triangular prism. So your triangular prism is going to be 1/2 because it's triangle. So it's like a rectangular prism where you multiply your 3 dimensions together, your width, length, and height together, but then you take half of it because of the triangle. So when you multiply all that together, you get 27/8 x cubed equals 1,000 divided by 27/8, then cube root, and you end up with x being 6.666, or to 3 significant figures, 6.67. moving on, this is our last question here, but it's a little bit lengthy. Brad traveled from his home in New York to Chamonix. Okay, so here's all his travel plans. What you have to do is find the overall average speed. Well, average speed is total distance divided by total time. Okay, so read the question carefully. You're finding overall speed or overall average speed. So total distance over total time from New York to Chamonix. Show all your work and give your answers in kilometers per hour. So what we would need to do is we need to keep track of time, overall distance divided by total time, and we need to keep track of distance and time. Okay, so here we go. We'll put it down to right here. I think, well, we need it right here. So he leaves his home at 16:30. So right here, I start with 16:30. Takes a taxi to the airport. This journey took 55 minutes. So here's 55 minutes. And when you add that on, you're now at 17:25. So the 55 is how much time it took. 17:25 is what's on the clock. And an average speed of 18 kilometers per hour. So if you take 18 kilometers per hour, multiply it by 55 over 60, 55 minutes out of 60 minutes, that will give you your decimal of an hour. 55 divided by 60 is your fraction of an hour. Multiply it by your 18 kilometers per hour, and it gives you 16.5 kilometers. Here's our distance. Remember, we're keeping track of total distance and total time. So this is where we're at now on the clock. And then he travels by plane to Geneva, departing from New York at 22:15. So 22:15 minus the 17:25 means he waited in the airport for 4 hours and 50 minutes. So this is a part of the time that we need to keep track of, total distance by total time. Okay, but on the clock, it's now 22:15. That's when he leaves. And he's going to Geneva, which is 6 hours ahead of New York. So in Geneva time, 6 hours ahead would be 4 o'clock and 15 minutes in the morning. 22:15 is in the evening. Bump it up 6 hours for Geneva time is 4:15 in the morning. Okay. Now the flight path is this arc. This arc has a radius of 6,400 kilometers with a sector angle of 55.5 degrees, and he arrives at 11:25 the next day. So for time, arrives at 11:25, that's Geneva time, minus the 4:15 Geneva time when he left New York, means he traveled 7 hours and 10 minutes to get from New York to Geneva. So this time is part of our overall time that we're keeping track of, travel time. So distance, we have 55.5 degree sector divided by 360. The perimeter or the arc of the circle is circumference, so 2 pi r. Circumference is 2 pi r, and we have a fraction of the circumference, which is the arc the plane takes, which is 55.5 degrees divided by 360 total degrees. You multiply this out. This comes from your sector area and arc length that you had in IGCSE material. You get 6,199.41 kilometers for this section. Obviously, there's no kilometers while he's waiting at the airport, but there is time. Then, to complete his journey, he takes a bus, but the bus doesn't start until 1300. So from 11:25 to 1300 is 1 hour and 35 minutes. So that's how long he's waiting for the bus to leave the airport. And it takes the bus an hour and 36 minutes to get to his destination. So he arrives at 14:36 because Chamonix if that's how you pronounce it, is the same time as Geneva time, so arrives at 14:36. So this hour and 36 minutes, and the bus is traveling at an average speed of 65 kilometers per hour. So 65 times the 1 hour and 36 divided by 60. Don't put 1.36, it's 1 plus 36 over 60 because it's in minutes. And that will give you your decimal of an hour, 1 plus 36 divided by 60 times the 65 will give you 104 kilometers that the bus traveled. Now what we want to do is we want to get total distance divided by total time. So the distance is 16.5 plus 6,199.41 plus 104 will give you this 6,319.91 kilometers. And then total time, what we're going to do is we're going to go add up the whole numbers first. 4 plus 7, so 7, 8, 9, 10, 11, 12, and then 13. So if we add up the whole number hours, we get 13 hours. Now I'm going to go and add up the minutes. So if you take 55 plus 50 plus the 10 plus the 35 and then plus the 36, you're going to find out that you end up with 3 hours and 6 minutes. So if you add those up and you divide by 60, you're going to get 3 full hours with 6 minutes left over. So that gives us 16 hours and 6 minutes. Again, we want to change it to a decimal. So it's 16 plus 6 divided by 60, and that changes it to a decimal, 16.1 hours. So our average speed is now 392.54. To 3 significant digits is 393 kilometers per hour is the average speed. Notice this is 11 points, so you have a lot of time. 11 points, you have at least 15 minutes there to work on this problem. So you just need to slowly work through it one section at a time. And remember, average speed is total distance over total time. So pay attention to finding distance and time at each interval. Don't forget the time waiting, and don't forget to convert your speeds times time to get distance. And when you change minutes to a part of an hour, you need to divide it by 60 to get a decimal of an hour. Okay, so you should end up with 393 kilometers per hour. So there we go. That is our paper 41, May-June series 2019. It's a 2.5 hour long test. So I hope this helps you. Thank you for joining me and hope to see you again next time.